Object, the root of all classes. This is in .NET. Everything is derived from system.object. We're going to talk about the methods that are a part of the object that you can get from any object that you're using within the .NET universe and C#. We're going to talk about equals, which is going to allow you to test for equality of two objects. And there is a static or an instance method, and we'll talk about that, and we'll override this to create our own functionality. To string, this is the string representation of the object. If you're working with a reference type, you're working with a particular class, then it's going to return that class name, as opposed to what you might expect returning a string equivalent, but we'll show you how to override that as well. Finalize, this is going to clean up memory resources, working with the destructor, and there are some details concerning garbage collection that you need to look into. And finalize is one way to help clean up memory resources. Reference equals. Now this is going to allow you to test whether or not two objects are going to refer to the same instance. Sounds kind of like equality, and we'll look at the differences between the two. There's only a static method for doing that. Get hash code. This is going to provide a unique integer for the object's value. This method is going to return a numeric value, and it's really used to identify an object in memory. And it's also commonly used with hash-based collections. We'll look at this as well. Now get type, this allows you to get the type of the object, and you can do this with your value or your reference types. Member-wise clone, this is going to create a shallow copy of the object. And this is really concerning the reference types, because a shallow copy is only going to copy all the instance fields of the object that are value types. And we'll look at this and the details at the end of this video that you need to make yourself aware of. Every method of object is available in all objects in the system, as I mentioned. Some methods are really intended to be overridden, and that would include the equals, finalize, get hash code, and toString. And we're going to look at some of these in our example. Now, again about member-wise clone. Now, member-wise clone can't be overridden, and it only does a shallow copy, like I mentioned. If you want to implement the iClonable interface, this is going to allow you to create a deep copy. Now, a shallow copy creates a new instance of the same original type, and then it's copying the non-static fields of the original object. Now, if a field is a reference type, this is the important part to understand. The reference is going to be copied, but the referred object is not going to be copied. So you get the reference, but you don't copy the referred object, only what it points to. So the reference in the original object and the reference in the clone are going to point to the same object. Very important. In contrast, I mentioned a deep copy. Now, a deep copy is when you duplicate everything directly. Or it could be indirectly when it's referenced, but it's copied. Everything is copied directly or indirectly. And this is dealing with the fields in the object. So just to say it again, a deep copy of an object duplicates everything directly or indirectly referenced by the fields in the object. So it's a deep copy.